Hello everyone, I'm Khananagi KDPH on the registration number AG 2020 4003. So I am describing the project that I have done in the big data module. So the project name is Kafka Order Processing Pipeline. So this is a project this project is a real-time order processing system which built using Apache Kafka, Kafka JSON, Avro serialization, and it simulates an e-commerce order stream, process the incoming orders, which perform resize and failure handling, and also sends the fail messages to the declarer queue. So in this project, the architecture contains order producer, which continuously generate orders, and order consumer, which processes orders with retry logic, Avro schema, which ensures strongly typed structured messages, and data queue producer inside consumer. It stores permanently failed messages, and also Kafka broker. It has a via Docker, yeah, which has a message stream platform. So now I'll uh, I'm going to run the project. Just okay. So first I bring up Kafka using Docker. Just wait. Let's go to the terminal and like okay. Now I'll confirm now I have to confirm the services are running. So I'll type uh, okay, the services I can see the services are running. So next, I start the consumer. So it is ready to receive messages. No, okay. So I'll start consumer. Okay. So consumer is now connected. And now I the terminal and now I start the producer which streams the orders to Kafka. So okay, producer is also connected. So now you can see here. So you can see the consumer processes each order. It retries and failed ones also, and it sends permanently failed messages to the data queue. So okay, now I'll explain the core features of the project. So first one is it has a real-time order stream generator producer. So this producer creates random orders every 2 seconds. This producer creates random orders every 2 seconds uh, and encodes them using Avro for schema validations. Okay. Okay. So, and after that, the producer sends serialized binary Avro messages to the order store. Like here. Order is serialization. Okay. Okay. Next, I'll describe about consumer. Okay. So the consumer subscribes to the orders topic and decodes the error messages. So it It has features like random 10% failure simulation, 3 retry attempts per order, exponential back-off retry timing, and running average price calculation. If it all retries fail, then message move to the data key. Okay, so that's about the consumer. So you can see in here, you can see it loads the arrow schema and read configuration retries, track your attempts, and simulate random 10% failures like this. Okay. Okay. So this is the when after retrying after three retries, it sends to the data queue. Okay. Okay. So now I'll describe about the data queue. So data queue has messages that consistently fail produce processing get sensed. Okay. So it has the original order, error message, and the timestamp. Okay. So it has implemented the consumer. Okay. Uh, okay. There's a message. Okay. So in here it has order. Alright, okay. Okay. So okay. So now it also has a feature like Kafka client configuration. So Kafka JS is used as a Kafka client. So configuration, you can see the configuration with Kafka JS. Okay. In here, you can see the configuration. So you can see client ID, broker, and topics in here. You can see client ID, brokers, and like that in here. Okay. And the project have some required packages like Kafka JSON, Euro serialization library. Okay, so like that. So in schemas, so in here, your order AVC okay, and type name record and like that. Okay. Okay. Now I will explain the how the system works. Okay. So first, in order producer, it generates an order every 2 seconds, and then it serialize the order using Auro, and then it publish to the orders topic. Okay. After that, the Kafka broker, okay, it receives and stores the in the order stream, and it distributes the messages to the consumers. And in the customer, in the order customer file, it reads messages from the orders and then it deserializes with arrow, and then it processes the order and then calculate the running average, and in on failure it triggers every retry logic, and after 3 failed retries it sends the data queue. In the data queue, it stores the messages for manual inspection, and also it prevents the main consumer from getting stuck. Okay, so that's all about my project again. And also like we can see like this in real-time applications also. So these like patterns used in like e-commerce platforms, like in order processing pipelines, like financial systems and IoT platform, logging system, and also some inter-service communication microservices as well. So thank you for the active participation. Thank you.